Friends, welcome you all in today's last session of the teleconferencing. Our experts felt that this is the very important topic of the loss reduction. So we will continue with this topic. I would request Mrs. Chandra to continue this lecture.
Thank you, Rakhi. So we were talking about voltage boosters, automatic voltage boosters. We had said that the automatic voltage booster is like a load tap changer. The advantage of automatic voltage booster is that multiple units can be installed in series on any feeder to bring the voltage drop of even highly ill-conditioned feeders, say 30%, to statutory limits. It is the best interim arrangement to meet the statutory requirements of voltage drop in the event of violation due to unexpected load growth, as the automatic voltage booster can be installed quickly wherever required, and it can also be shifted easily whenever voltages are improved on completion of system augmentation works. So that it is like a voltage booster, a voltage stabilizer, and it can be easily installed and easily removed. When we come to improvements in joints, bad joints, bad workmanship results in poor contacts at joints, which results in higher losses. So the number of joints should be minimum and each joint should be firm. Joints at bushing rods, stems, at dropout fuses, isolators, LT switches, fuse links, everywhere you should take care of joints. In fact, in a World Bank study conducted at Haryana, it was found that the losses due to bad joints alone were around 3 to 4% of the total loss. And this loss is not being considered anywhere in our system. We don't count this towards loss. Towards loss we only consider I²R loss and loss in transformers. But actual studies indicate that losses can be as high as 3 to 4% in joints. So these joints should be very carefully made. Sparking and heating at contacts should be avoided. You should have prompt replacement of deteriorated wires wherever sparking is occurring. So to find out where about the joints, we can now use thermography. Use of infrared cameras to monitor hot spots and loose connections can be made. Now earlier these infrared cameras were being used only for transmission systems, but with the increase in technology, in the technological developments in the world, the cost of these infrared cameras has come down substantially, and these can now be used for distribution systems also. All hotspots on the lines in the switchyards should be having a fixed periodicity for examination by cameras to minimize expensive burnouts and breakdowns of the equipments. These infrared cameras actually indicate the temperature of the joint. The basic idea of using this is that if the joint is at a good temperature, then it will have a different color. If it is red, it is at a higher temperature, it will have a different color. So various color grading shows the temperature of the connection or joint, and you can use this to find out which joint is going to break down. Then PG clamps. In case PG clamps are used, the PG clamps should be of adequate size, and GI nuts, bolts with spring washers should be used if these are used for clamping. All PG clamps need to be retightened after around 1 year, as the clamps become loose and a layer of coating gets deposited on the contact surfaces. So you should re-examine retighten all the PG clamps. It is best to have a sleeve joint and crimp the joints with a crimping tool. Quite often joints are made by wrapping the conductors with GI wires. While making the joints, the two ends of the cutout standard conductor will tend to get loose. Loose strands are often a cause for heating and related damage. The recommended practice is to wrap the loose ends tightly using GI wire before making a joint. In case of cables, improvements in joints in terminations have come up. Earlier we were using cast iron molded joints and terminations, which are now obsolete. Cast iron molds were used for top and bottom covers. Conductors strands are soldered, taped, and bitumen compound is used for insulation. These were used only for paper insulation cables but are now obsolete. The other improvements are that for mid-span joints, tension jointing of bundles in mid-span must be avoided. At erection where a choice exists, the bundles must be joined at the non-tension bond position of a pole top. For shackle joints, the jumper connector at shackle joints is better with PG clamps, but it is advisable to use crimped or fire wedge connections. Other improvements in joints and terminations are the epoxy resin type joints and terminations. This is used for all types of cables wherein resin and hardener are used for providing insulation in PVC top and bottom molded covers. Insulating materials after setting becomes hard, which gives mechanical protection and does not allow moisture to enter in the cable. Then there are the heat shrinkable joints and terminations. All the insulating screen materials are supplied in tubes having the characteristics of shrinking in hot condition. Tubes are slid and shrunk to the cores by using blow lamp. Care has to be taken for shrinking tubes properly with correct temperature and without allowing any air pockets inside them. Aluminium or brass covers called canister are often used for mechanical protection, over which PVC outer sheet sleeves are shrunk. Then we also have the cold shrinkable joints and terminations, where you do not want to heat with a blow lamp. The tubes are provided which are having the features of shrinking in cold condition. The tubes are held in suitable dimensions by means of helical nylon spirals inside, and after preparation of the cores, these tubes are slided to one side. On pulling of the nylon spirals, the tubes get shrunk to the core, providing necessary insulation. Then we have the push-on type joints and terminations. The pre-molded tubes are pressure fitted or pushed onto the cores and making earth arrangements similar to the other joints and terminations. The heat shrinkable, cold shrinkable and push-on type joints and terminations do not need any sitting time and can be taken into service immediately. The epoxy resin type of joint and termination requires some setting time for the epoxy to get hardened, but these types do not require any setting time. I think we can. Then increase in HT-LT ratio. In our country the HT-LT ratio is quite skewed. It has about 3 in our country. That means the LT lines are about 3 times the HT lines. So we need to reduce our LT lines and increase the HT lines. Because in case of HT, the current is reduced. When the voltage is increased, the current is reduced and losses are reduced. For 100 kVA load, amperage at 11 kV is 5 amperes, whereas at LT it is 140 amperes. So loss
this ratio is LT to HT.
So it can be HT to LT or LT to HT.
No, LT to HT can be high, no, if LT is more.
Yes, then it will be the reverse in HT.
So in your slide you are showing 3.
Yes, okay. LT to HT is 3 times. That is what I said. So for this we need to upgrade our voltage levels. We have a low voltage, as we discussed, low voltage distribution system in which the capacity of the transformer is high and we take long LT lines. But by upgrading the voltage level, we take the distribution at 11 kV and make the size of the transformer smaller, then it becomes high voltage distribution system. So high voltage distribution system is a method of increasing the HT and reducing the LT. The existing LV distribution system is changed to high voltage distribution system by extending HT line very close to loads and installing small size transformer. LT less system is to be achieved, but we start from less LT.
Yes, Delhi, please ask your question.
Excuse me, ma'am.
Yes.
I want to ask about the ST-LT ratio in previous slide.
Yes.
ST-LT ratio was showing about 3. It is LT,
It is LT
or
to,
ST-LT ratio?
no, it is LT to HT. HT to LT will be 1:3. LT is 3 and HT is 1. It is LT to HT ratio.
The next slide also there is similar thing.
Yes.
So it's, we are sorry for this.
So this is
There is some.
this is the example of a small transformer. Transformer installed on a pole. This small transformer could be 10, 15, or even in Rajiv Gandhi Gramin Vidyutikaran Yojana we are now thinking of going for 5 kVA. So the 11 kV line is brought very near to the consumers, and 3 or 4 or 10 consumers are fed from a small capacity transformer. The advantages of HT distribution system are that small size of conductor is used, because at HT, as I said, if the current in HT is 5 ampere, it will be 140 ampere in LT. The voltage profile is better, direct tapping from the line is avoided, and line losses are substantially less. People generally do not tap 11 kV line. You have to have a transformer to tap an 11 kV line. Only then you will be able to make use of it. So the reliability also improves due to the following reasons. Faults on HT line are much less in comparison to faults on LT lines, and since a limited number of consumers are fed by one transformer, the fault in the same does not affect other consumers. Theft of electricity is practically eliminated in such systems because of 2 reasons. One is that you don't tap an 11 kV line. Secondly, because there are only 3 to 4 customers on that transformer. One customer, the customers on that transformer tend to see that the other customer does not steal electricity, because if the transformer is overloaded and gets it is destroyed, then only those 3 or 4 customers will be affected. So they try to ensure that your neighboring customer does not steal energy and overload the system.
Yeah, madam, the stealing electricity is different than overloading the
So
transformer.
because if you steal, then it gets overloaded, because this transformer
stealing
is
is
designed,
That's
actually
right.
sir, let me explain this.
Yes.
The transformer is designed for a certain load, and if you put more load, if
Yeah.
there are more customers, or if you put more than what load has been sanctioned, then the transformer is going to get overloaded and it is likely to burn off.
So you have to provide the proper capacity transformer, and the load sanction
Yes.
has to be there. They
Yes,
must
sanctioned
not
load-
exceed the sanctioned load.
Yes. You should not be putting more load than the sanctioned load, and when you steal, you try to put
So they must
more.
apply for a fresh increase of the load.
Yes, that is true.
In that case, you will have to change the transformer. So
There, of course,
better practice perhaps in my opinion would be that you take a margin in the transformer capacity and check the theft of electricity by some other means, and otherwise they take a less connection, you provide a lesser transformer, and then you change the transformer. It would be a wastage of investment of the distribution company.
because most of the loads in most of the areas you see a sanctioned load of domestic load of 1 kilowatt or 2 kilowatt, whereas everybody has installed an AC in the house, he has a geyser, he has a microwave, but they have not asked for a new sanctioned load. So actually
okay.
this happens that they are using much more load than was sanctioned earlier.
No, that's okay. My point is that the distribution company must foresee
Yes.
that what would be the load growth,
It does
time.
that, but still it becomes overloaded because it cannot foresee the theft of electricity from the transformer. It keeps a margin, but still it cannot foresee the amount of theft which will be carried out from the transformer. That is unexpected. So conversion of the existing LT system to high voltage distribution system can be done wherever clearance is available. That is very important, wherever clearance is available, by replacing LT conductor with 11 kV conductor on the existing poles, and install small capacity distribution transformers and energize 4 to 10 consumers from each transformer. If clearance is not available, then
You go on talking.
then you will have to install either risers on the pole or replace the pole. If the pole height is much less, you can increase the height of the pole by putting a riser on the pole. If you compare the HT distribution and the LT distribution, then if for the distribution of same quantum of power, the comparison of losses and voltage drop is as below. For 100 per 100 as LT base we have taken. If the current in the LT system is 100, then in HT system, that is single phase HT high voltage distribution system, the current will become 11 ampere. If the losses in 3-phase LT distribution, 4-wire LT distribution system are 100, they will become only 8.5 kilowatt in the high voltage distribution system, and the voltage drop, if it is 100 volts or kilovolts, it will become 12.7. So you can see the advantages of high voltage distribution system as compared to low voltage distribution system, and it is very much recommended to contain technical losses as well as commercial losses. You can see the technical losses also come down very substantially from 100 to 8.5 kilowatt. So these were some of the short-term measures which we can take. As we discussed, the short-term measures are measures which can be taken in 1 to 2 years. But long-term measures are those measures which can be taken in the next 5 years. And the utility has to plan to take these, has to do planning and system studies for taking these long-term measures. And these are taken to, actually these measures are taken to meet the, improve the system for reduction of losses as well as to meet the future load demand. The demand incident on the system in the next 5 years also has to be taken into account. So long-term plans are built with the objective of ensuring quality and reliability of supply to the consumers, bringing down technical losses to an optimum minimum value, and phase the system expansion to meet the growing power demand in the area under study. That is how you prepare long-term plans. The activities for preparing long-term plans are: you have to first collect data regarding existing loads, operating conditions, then forecast the loads, expected loads on the system, right from grid substation up to consumer level. And the methods of forecasting are many, but in our country we are generally using the end use method. Then you have to map the existing system, and you have to carry out.
Where I think I interjected in between when you were
Yes.
saying that you cannot foresee the theft. When in our demand projection, theft is not a consideration. We find out the end use method, what would be the growth of consumption like. So if you know that what would be the growth of consumption, there is no question of theft in sizing of your transformer, etc. Theft is from the point of view he doesn't want to pay for it. And therefore you must envisage that in the next 4, 5 or 10 years, what is the load growth like, how the consumptions will grow, how the standards of living will grow, what appliances people are likely to have. So like in rural, for example, we envisage that in next 5 years, the rural will also start using the washing machines, the refrigerators, for example. So we have to consider that load.
Exactly.
So you size the transformer accordingly, because it cannot.
That is what one
it is not
usually
feasible
do.
that frequently, suppose you find your transformer is getting overloaded, don't change it. So theft is a separate part, and sizing of the transformers and lines is a separate part. Okay, you can go ahead.
So we were talking about what are the activities to be conducted for preparing long-term plans. We need to collect data regarding the existing loads. Then we need to map our existing system. By mapping we mean that we have to map each section of line, each conductor size, each transformer with its capacity. Everything has to be mapped out. And there are various methods of mapping.
Yes, Bhopal, please ask your question.
Good afternoon, madam. If DC transmission can be used for reduction of losses?
Pardon?
DC transmission system.
DC transmission system.
DC transmission lines.
DC transmission lines. Okay, yes. These DC transmission lines are not being used in the sub-transmission and distribution system. They are only used in the transmission system. And
the losses are lower.
The losses are lower, and you use DC for transmission of huge blocks of power from one region to another. The criteria is more towards transfer of huge blocks of power rather than loss reduction. And mainly though losses in DC will be less as compared to the AC system.
High voltage line, corona loss will be less.
Yes.
We have used the DC transmission lines in the various regions, mainly as Anjali has pointed out, from the considerations of controlling a controlled transfer of the power from one region to another region, because we did not have the national grid. After, of course, now out of 5 regions, 4 regions are already interconnected, and therefore the DC lines were used like a control valve. But now in the 11th plan, a large number of DC lines are also planned. They do give the low losses in the lines.
But actually we are not using it in distribution, because conversion of AC to DC and then again conversion from DC to AC would involve a huge cost.
It's economic.
It is not an economic
Yes, it is economic.
viability. The feasibility of conversion first from AC to DC, then DC to AC.
Efficient.
It will be very expensive.
Sufficient.
So using it at distribution level for reduction of losses would not be a viable alternative.
So the question was about transmission only.
Yeah. We go over to, we were talking about activities for preparing long-term plans. We have to map the existing system, get all the data, then analyze the system for what is the voltage regulation and T&D losses in the existing system and adequacy of the backup system in the existing condition. I don't know. There's some problem in this.
So there is a request from all the RCs and study centers. Please send attendance of the students
Okay.
by fax.
Okay, we were talking, then we have to make the load forecast. And we make the load forecast for, one is the global load forecast, taking into consideration what will be the losses in the system and what will be the consumption. This load forecast for distribution systems is generally made for 5 years. Then the global load forecast is divided into a spatial load forecast, because in distribution systems we have to do spatial planning. We have to plan for small areas, so we divide the load forecast into smaller grids, forecast for smaller areas, and we superimpose it on the system, see what will be the losses in the existing system if this demand was also to be met, and generally that the system will get overloaded, and considering this we plan for upgrading the network, and those plans are prepared where we will need upgradation for meeting the forecasted load as well as for reduction of losses, and we include various technology options for modernization of the system. And there are various alternatives of meeting this load, and we evaluate each alternative to find the least cost solution. Least cost solution means a solution which considers the capital investment in the plan as well as the cost of losses over a lifetime of the equipment. So the taking both into consideration. Yes.
Yes, Mumbai. Please ask your question.
Hello ma'am, I would like to know if the present system of 230 volts system at consumer level could be changed to 127 volt or 115 volt, which is going to bring down the losses.
I don't think.
There is no proposal to bring down the voltage at the consumer end from 230 to 110 volts, because if you, as we talked, the higher voltage you go to, the losses will be less. But at consumer end, there is no proposal to bring down the, because if you are to have a 110 volt system at the consumer end, then your LT lines have also to be 110. And the current in the LT lines will be much higher, corresponding to 110 volt as compared to 230 volt. So it will not bring down losses, it will increase the losses if you go down to 110 volt at the consumer end.
Yeah.
All the appliances should be has to be designed on same rating.
No, everything will have to be designed, but even if you do bring it, your losses are going to increase, not decrease. So when you prepare the long-term plan, you will have to carry out augmentation of the transformer capacity at the existing 66 or 33 by 11 kV substations. You will have to rearrange, reconfigure the 33 by 66 kV feeders by using higher size conductors or by increasing the number of feeders. You will also have to establish new 33 or 66 by 11 kV substations nearer to the load centers. All these three have to be considered while preparing the long-term plan. You will redistribute the load between the existing and new substations, carry out feeder strengthening, addition of new 11 kV feeders and reconducting of existing feeders, addition of distribution transformers and LT lines, and also adopt modern technologies. To find out which is the best solution, you have to use softwares for carrying out system studies. Because the distribution system is very wide, it is not possible to carry out voltage drop calculations and loss calculations by hand. We had earlier been doing the kVA kilometer method, but it is very approximate and it is quite, with the extension of our distribution systems, it is quite tedious and very cumbersome to do it manually. So we now have software tools available to develop the long-term plans and carry out system studies, load flow studies for finding out what will be the voltage drop in each section and what will be the current in each section, and find out the total losses. Very many software tools are available. I have listed some of the companies. We have like Sine from Trident Technologies. It is marketed by Trident Technologies in India. We have PowerNet, which is marketed by GEC Hyderabad. We have many distribution softwares. Scott & Scott has now, earlier it was marketing it as DPA, but now it is marketing it as Synergy. We have Millsoft from Millsoft software. So we have various softwares, and these can be used for studying the distribution systems and preparing long-term plans. Then we come to methods for reduction of commercial loss. I think there was a question about this reduction of commercial loss. So the commercial loss is total loss minus technical loss, and it causes a lot of revenue loss. And who benefits from these? It is the anti-social elements, the immoral political abettors, and the unscrupulous industrialists who are benefiting. The common man generally does not benefit.
Yes, Kolkata, please ask your question.
Madam.
Yes, ask your question.
Madam, my question is, what the maximum amount of power in megawatts that we can transmit in 11 kV feeder to maintain the loss within 4%?
Okay, well,
what could be the maximum length of the feeder?
Okay. The maximum amount of power which one can transmit over a 11 kV feeder will depend upon the first the size of the conductor, second it will be the power factor. So the power factor of the load. So for different conductors we can carry different amounts of power because the current carrying capacity is different. You'll have to calculate how much is the current carrying capacity, and from that you will work out how much is the power that can be carried over an 11 kV feeder. It can vary from say 2 megawatt to about 5 megawatt, depending on the current carrying capacity. It also depends on the length. You generally don't only calculate how much power can be drawn, it depends on also the length of the feeder and the loading at various points. So you generally consider the MVA kilometer or the KVA kilometer loading. You do not consider KVA now power drawn because it depends quite a lot on the loading of the feeder. And secondly, you said how much should be the length of the 11 kV feeder. The length of the 11 kV feeder again depends on the loading of the feeder, at what point is the loading. But as a thumb rule we are saying that the 11 kV feeders in urban areas should not be more than 5 kilometers, and in rural areas it should not be more than 10 kilometers. When we were talking about theft of power, the theft of power is a very big menace, and I think it is the sole cause of all ailments of power utilities. It leads to transformer failures, breakdowns of supply, customer dissatisfaction, commercial losses, poor collection of revenues, increased technical losses. Once the commercial losses are high, it will lead to an increase in technical losses also, and a crisis at times of shortage of supply. It also leads to accidents, poor credit worthiness of the utility, corrosion of integrity of the employees, non-development of the network to suit the new needs, low frequency and grid tripping, unscheduled power shutdowns, and bad image for the utility. That is why containing commercial losses.
Yes, Daddy, ask a question.
Is there any possibility of recording or reverse readings in downloadable electronic meters?
Reverse?
And is the MS applicable in new static electronic meter also?
What is MS? Pardon, can you repeat your question? What is MS applicable?
MS applicability is...
You mean microphone?
It was applicable in the mechanical meters earlier. Now it is in the syllabus, in this lecture given. MS for billing as change in MS is also counting for our loss in billing revenue. Because if MS is suppose 10 and we are billing at the rate of 1, then we are having a less billing. So it is causing commercial loss.
Could you expand on MS? What is MS? You want to say?
Multiplying factor.
Okay, multiplying factor. Yes. It is not possible to have reverse reading in electronic meters while you are downloading. The downloading instrument, which is the MRI or the CMRI, common meter reading instrument or the meter reading instrument, it is plugged into the optical port of the electronic meter, and the data comes just like what comes in a floppy or in a CD. So it will come as it is from the meter. So I don't.
But whether his question pertains to whether the electronic meters can record a reverse reading and the bill can be reduced.
No, it will not record
perhaps
a reverse.
if someone injects some high frequency.
So that time though anything can happen because the pulse will become erratic.
So
that is in case of tampering of the meter by injecting a high voltage, but in regular conditions there is no question of.
But technically it is feasible.
Technically, when there is an injection of a high voltage, the pulse will get erratic. So what reading it will record will depend on how much of how the electronic circuitry reacts to that pulse.
That is normally used by the people to reduce their bills or something.
Yes, it can be used, and it is being used. It is one of the methods for tampering. And if the multiplier factor is not proper, then your bill is definitely going to change. You have to use the proper multiplying factor. If your reading was to be multiplied by 10, and if you multiply it by 1, then naturally you are going to charge for 1/10 of the amount. So for stopping theft, we'll discuss the various measures. One is you can create vigilance squads. Actually, vigilance is very important in stopping commercial losses. You need to have vigilance squads which will conduct raids. The officer who is in charge of the system cannot do this because he is quite preoccupied in the various jobs of maintaining the system and getting bills from the consumers. So, and they can be easily influenced because they are in direct contact with the people. We need separate vigilance squads who have specialized knowledge of various meters and the modus operandi being used by the consumers. And they should conduct raids. We should have people who have knowledge, tact, tenacity and integrity, as they will be dealing with cases involving influential people, and they will be deciding on huge amounts of money. So these people should be selected very carefully who conduct vigilance raids.
On this issue, I would like to add that these vigilance people are to be highly trained people who must maintain a very cordial and good relations with the consumers. They should be welcome to their people. They should also do the job of guiding the consumers. What is required to be done, how to save electricity, and they should be allowed to enter the houses anytime. They must be welcome. I have seen this in Gujarat. Gujarat have created an army of people of these distribution companies who maintain very cordial relation with the consumers. They will go to the houses, take tea and guide them, and also give them some tips how to save electricity, switch off this fan, that light whenever you are, whatever you are doing, how to consume electricity in the most optimum manner. At the same time, then they also detect in this process if there are any consumers who are using unfair means to steal electricity, and they have actually practically stopped stealing electricity in that area.
Yes.
And so you have to create, you see, one is by law, by strictness, by taking penal actions against the people. Another is by increasing awareness to people and convincing them that you should not steal electricity. It is an offense and it is an antisocial activity. This way also things can be approved. So it has to be a combination of both the measures.
So we were talking about carrying out surprise inspection by vigilance squads. Then we should also have periodic inspection of LT feeders by the special vigilance squads for tracing unauthorized consumers and direct tapping from the line. They are visible, and we should keep on having periodic inspection to see that nobody hooks the line. We should also launch prosecutions, proceedings against persons indulging in theft of energy to secure convictions in the court. The Electricity Act 2003 is quite emphatic on incriminating material. Therefore, whenever vigilance squads visit, they should collect the materials, wires and equipments and preserve them for providing them at the time of court hearing to prove the crime. Then further, the fines should be imposed on consumers found committing theft of energy, and you should start a drive for regularizing unauthorized connections and simplifying procedure for release of new connections to consumers, so that they voluntarily come forward for taking a new connection. If the procedure is very cumbersome, then it is easier to hook than to come forward for a connection. And you should conduct regular drives for regularizing unauthorized connections. So people are not only prone to tapping from the line, but also steal electricity from the distribution transformer secondary also. You can see here a consumer has tapped the distribution transformer secondary. You have to guard against such thefts also. You can use aerial bunched cables or partially insulated LT lines. Like we were talking about aerial bunched cables. Aerial bunched cables or in partial insulated LT lines should be used in theft prone areas along with high voltage distribution system. One is that you make it high voltage distribution system, and the LT lines should be aerial bunched cables. And it is difficult to tap the cable, so your losses are going to become much less. Instead of bare insulated, bare overhead conductor, you use LT aerial bunched cable for giving supply. The advantages of aerial bunched cables are diameter of the conductor bundle is less than that of 4 bare conductors. The loading caused by wind, snow and ice is decreased, and therefore their support poles can be placed further apart and fewer stays can be employed. The aerial bunched cable can be erected on the same poles as are used for street lighting and telecommunication circuits, saving considerable investment. The number of accidents are reduced, you have higher reliability of supply, and reactance of the AB cable system is very low. Therefore, voltage drop on a LT distribution feeder for transmission of same amount of power is low in aerial bunched cable system. When voltage drop is less, your losses will also be lower, and the maintenance costs are much lower. Then you should, as said by Mr. Verma, you should have a public relation and awareness campaign by the utility. Change in the value system of the society is also needed. The opinion makers and social leaders should be involved to effectively tackle this massive social evil. Some amount of public relations work by the utility is needed to tackle this. You should tell the people about what they are, how they are harming the society as by doing this theft. It is to be widely publicized that theft will increase the tariff for the genuine consumers, result in poor voltages, burnt motors, failed transformers and dried crops. If you have load shedding, then your crops will also dry off. And the square resources of the state meant for social welfare are diverted to feed these power thieves. So we need to have a public awareness campaign that theft, what are the harm to the society by these people who are indulging in theft. Then what are the measures that we can take for controlling pilferage of energy by existing consumers? They are consumers, but they tend to tamper the meter. So the mechanical meters tend to slow down over a period of time. We should have electronic meters for the consumers. We should have CT meters for high value services and install meters with tamper logging features. The electronic meters should be such that they have tamper logging features. Non-working and defective meters should be identified and replaced. Unmetered supply should be metered immediately. Electricity Act 2003 contemplates metering of the services within 2 years and visualizes action on the company and the individual officers responsible for lapses. Though a relaxation has been given in Electricity Act that the State Electricity Regulatory Commission can extend the period of time for installation of meters for non-consumer, unmetered consumers for a given period of time, for example in agriculture. Then severe penalties may be imposed, and these penalties are also indicated in the Electricity Act. Theft of electricity should be publicized as a social and economic crime, and people should be informed of the provision in electricity laws in this regard. Now this, under the Electricity Act, this has been made a cognizable offence, so this should be made known to the people. Then there should be a scheme for classification of consumers based on ABC analysis, and action should be taken for high value consumers, because where the high value consumers steal, then the utility gets a greater loss of revenue than for small value consumers. So most of the revenue, 70 or 80% of the revenue comes from 5% of the consumers. It is these consumers which should be tackled first. And then energy variation in consumption must be regularly checked for all categories of consumers. If his energy consumption is varying very substantially, then that is the consumer which needs to be investigated.
So we have
Strict.
so we have limited time. So now the time has come to close.
Okay.
So do you want to wind up the session, madam?
Actually, yes, well, there were many other methods for reducing commercial losses, but since we don't have time for going into those measures, you can read them from the, you can go through the reading material which has been provided to you, and the penalties, there is a provision for setting up of special courts. There is also a provision in the Electricity Act for fine as well as imprisonment in case of electricity theft. So that should be widely publicized, I feel, so that to make people aware of what they are doing and what is the penalty if they are caught.
So we had very interesting and interactive sessions with our experts and our learners, and I hope these talks by the experts would help you immensely to go through your course and effective functioning and learning. And I express my sincere gratitude to Mrs. Anjali Chandra and Mr. V.S. Verma for spending their valuable time with us and enlightening us on various aspects of the distribution loss and concepts of the loss and loss minimization. And at the end, I express my sincere thanks to all the viewers and the learners of this program. I wish you all the very best in your studies. Thank you.
Thank you.
Good day.
Thank you.